In section 12.4, we'll be focusing on finding the volumes of prisms and cylinders. After watching this video, you'll be able to find the volume of right rectangular prism, find the volumes of other types of prisms, find the volumes of cylinders, and use the area of a prism's or cylinder's cross-section to find the solid's volume. Let's discuss the difference between two-dimensional and three-dimensional figures. When we've been working with area, we've just been working with two-dimensional figures. So the figure on the left would be an example of a 1 by 1 dimension figure. So it's two-dimensional. While the figure on the right would be an example of a 1 by 1 by 1 or three-dimensional figure. So in our two-dimensional figure, we were working with length and width. And for a three-dimensional figure, we're now bringing in that third dimension of height. So length and width and height. When we're finding the volume of a prism, it has to be a three-dimensional figure because by definition, volume is the number of cubic units of space contained by the solid. So we're looking for the amount of space that's inside of the figure itself. You could think about this in one way. You could think about this rectangular prism to be a stack of congruent rectangular sheets of paper. The area of each sheet of paper can be found by taking length times width. And the height of the stack would be h, which is the same as the height of the rectangular prism. Since the base of the prism is one of the congruent sheets, we can then find the volume of this rectangular prism by taking the area of the base, which is the yellow, and multiplying it by the height. Because if we could take that area of the base, multiply it by the height, it would fill up everything inside of that prism. Now, how do we recognize our bases? Now, sometimes the base will be shaded for you, especially in a rectangular prism. But it is very important to recognize that the base is not always necessarily at the bottom of the figure. The base has to be two parallel congruent figures. And then the height of the prism connects the two bases. So for example, if I were to use this base at the bottom here for the rectangular prism, because we weren't given a shaded base to begin with, so we were able to choose our base for a rectangular prism, since all sides of the prism are rectangles. Then the other base would be right here, this yellow base here, because those are two parallel congruent figures. And then the height of the prism would be this yellow segment here, which connects the two bases. We could think about the volume of the cylinder in a similar manner. This idea of the stacking property also applies to the cylinder. So, the base of the cylinder is what type of shape? It's a circle. So if we could just find the area of the base, which is congruent to one of the pieces of paper that would be in that shape, and multiply it by the height of the cylinder, that would fill up everything inside of the cylinder. So we could find the volume of a cylinder by taking the area of the base and multiplying it by the height, just like we did for the prism. But the unique thing about a cylinder is the base of the cylinder is always going to be a circle. So to find the area of the circle, we do pi r squared, and then we multiply it by the height. So we can find the volume of the cylinder. Let's take a look at one more idea. When we visualize the prism or cylinder as a stack of sheets, all of those sheets are congruent. So the area of any one of those sheets can be substituted in for the area of the base. So each one of these sheets would be considered an example of a cross-section. So in your book, if you see the C with the dash through it, that stands for cross-section. So we can also find the volume of a prism or cylinder by taking the area of a cross-section and multiplying it by the height of the figure. That works as well. Let's take a look at the first example together. For this, we want to find both the surface area and volume of the triangular prism. Surface area is going to be reviewed from a previous section. If we think back, we cannot have the base be the bottom shape. The bases have to be the triangles because they're two parallel congruent figures. So to find the total surface area, we have to find the lateral area of the figure and add on the area of the bases. Well, for the triangle, we know it's an 8, 15, 17 family, so we get that the other leg has a length of 30. And to find the lateral area, which will give us the area of the rectangles around the prism, we do the perimeter of the base, which is the perimeter of the triangle, and multiply it by the height, which is the red segment of 30, since it connects the two bases. So the lateral area of our prism is 2,400 units squared. But then we have to add on the area of the bases to find the total area, which are the two triangles. We find the area of each triangle by doing 1/2 of our base of 16 times height of 30, which gives us the total areas of the triangles to be 480 units squared, for a total surface area of 2,880 units squared for the prism. To find the volume of this prism, we have to take the area of the base and multiply it by the height of the prism. Well, the base of the prism is this one triangle here. So to find the area of that triangle, we have to do 1/2 of the base times the height, and then we have to multiply it by the height of the prism. Well, the height connects the two bases, which is that red segment of 30. So we're going to do 1/2 of our base of the triangle, which is 16, times the height of the triangle, which is 30, and then multiply it by the height of the entire prism, which is 30. We end up getting 7,200 units cubed for the volume. Please notice you have to put units cubed on the end of your answer when finding volume.